hello again. In this example, we are going to practice the generation of shear and moment diagrams for beams. We're going to look at this simple supported beam that has a couple of point loads on it. You will notice that the reactions are already provided for you. And another thing that's already been provided is we've identified where the load discontinuities are. So there's a load discontinuity, and we have put a dashed line on the set of axes for our shear and moment diagrams. I'm going to label that as the shear diagram. This is the moment diagram. I'm not going to put units on these because these ones we're using symbolics to deal with, but otherwise we would need to put units to make sure that our diagrams were well understood. Before we begin sketching the diagram, though, we want to plot the known shear at each end of the beam. Remember what our notation is. If a shear causes a clockwise rotation, that is a positive shear. If it causes a counterclockwise rotation, that is a negative shear. So this actually is a negative P over 3 because it causes a counterclockwise rotation of the beam. Now look at the right end of the beam. That also causes a counterclockwise rotation, so we know also that that is negative P over 3. Let's look back to the far left. So we're going to work from left to right, follow the rules. The change in shear from one location to another is the area under the load diagram. There's no load here, so that there is no area under that, so there is a zero change in shear. That will bring us then over here to this negative P over 3. Now applied load causes a jump in shear, so it jumps a total of positive P, which takes us from negative P over 3 to positive 2P over 3. Then the area under the load diagram, that's right here. There's no load, so there's no area, which means no change in shear. So we are 2P over 3. Now because of the point load, we have a negative jump, total magnitude of P, which will bring us, incidentally, back down to negative P over 3. Then going from that location to the end, there is no load here, so no area, which means no change in shear, which brings us back out to the point we already knew. Because we finished out at the point we already knew, that means we're confident in our answers, and we can proceed in connecting the dots. Since there's no loads in between the point loads, that means that our shear is going to be constant. So we will just go ahead and connect those as such. I'm going to just shade those in so it's easier to delineate that shear diagram. In order to do the moment diagram, it is going to be necessary to have the area under the shear diagram. So I'm going to go ahead and just write those on here. So the area here would be negative PL over 9. How did I get that quantity? I took this value of negative P over 3, multiplied it by the length there, that over 3, so I get negative PL over 9. This next area is equal to 2PL over 9, and this last area is equal to negative PL over 9. So next step is going to be plot the moment at the ends of the beam. Since there is no moment arrow there, we know it's a zero moment here, and likewise down here. Go back to the left, working from left to right. The change in moment from one location to another is the area under the shear diagram. So this will bring me down to negative PL over 9. Then the change in moment from one location to another is the area under the moment diagram. So take your negative PL over 9, that's this right here, and add on to it 2PL over 9. That will bring you up to this point, PL over 9. And then lastly, go from that point to the end by subtracting off this quantity there, and that brings me back down to 0. And so now I'm confident that I've done the computations correctly. Because my shear diagram is constant, my moment diagram is a set of first order lines. We'll go ahead and shade that in. I like to label these as first order. And if you want to, you can label these as being 0th order. So that's a 0th is what I've written there. All that means is constant. Well, this concludes this example, and as always, it's a beautiful day to study structures.